All right, Advanced Math A, here we go. We got lesson 7.1.4. We're going to justify triangle congruence using the flowcharts. So basically, we're just going to practice flowcharts today. Good times going to be had by all. All right, 7-42 says, yesterday, Joe found out that 3 people in his family, including himself, wanted to see a movie. So he went to the theater and bought 3 tickets. Unfortunately, while he was gone, 3 more family members decided to go. When everybody arrived at the theater, Joe did not have enough tickets. All right, so which of the following flowcharts captures this situation? So explain why or why not each of the flowcharts works. All right, so our first flowchart says Joe bought 3 tickets, 6 members decide to go to the movie, Joe doesn't have enough tickets. And you might be tempted to do this one because this is the order of the events that were written down. But the arrows in between are saying that one thing is leading to the next to happen. And this is basically indicating that Joe bought the tickets and that led to 6 members of the family deciding to go to the movie instead of the 3 that he thought. And that didn't really happen at the same time. I mean, it didn't happen because one happened before the other. So this is showing that there was one of these events leading to the next event. And that didn't actually happen. Him buying 3 tickets did not lead to 6 members of the family deciding to go to the movie. These were independent events, meaning that they happened independently of each other, not because of one another. So we're going to say on this one that this shows, so this is not going to work because this one shows that buying the tickets led to 6 members wanting to go to the movie. And that's not necessarily true. Just because he bought the 3 tickets, that did not lead to people buying the tickets. The next one says he bought the 3 tickets. That led to 6 members of the family going, which led to Joe not having enough tickets. And then this says that it leads to him buying tickets. So basically what's going to happen in this one is Joe is infinitely going to buy tickets and infinitely more people are going to want to go to the movies. He'll buy 3 tickets. 6 members will want to go. He's not going to have enough tickets, so he'll buy 3 tickets. So 6 more members are going to want to go. So this is going to go forever. This is Groundhog's Day right here. He's going to live the same day over and over and over again, and that's not what's happening. So this shows a circular event. With no end. All right, so we got Groundhog's Day going on there. It's not going to happen. Now, this last one makes the most sense because Joe buys the tickets, and then over here, independently, these two are not connected to each other. Independently, 6 people are going to just go decide the movies. Now, since he bought 3 tickets and 6 people came, that's what led to him not having enough tickets. These 2 events happen independently of each other, but they both lead to the conclusion that he doesn't have enough tickets. So this one is correct. All right, now we're going to do some proofs. Well, not proofs. We're going to do flowcharts, which are kind of like proofs. But what we're going to look at is we've got 5 different situations here with triangles, and we're going to see which ones of the situations are enough to prove the triangle is congruent. If they are enough, on a separate piece of paper, we're going to make a flow chart for that. So here's our first one. So far in our first one, I only see that this side and this, or this angle and this angle are congruent to each other. That's all I see. I might be tempted to say, well, I'm just going to move on. That's all I see. It's not enough information. But we could use the triangle angle sum theorem to find out what the measurement of J is. Let's just do that. So let's say that the measurement of angle J plus 56 degrees plus 29 degrees equals 180. Okay, so that's by the triangle angle sum theorem. I would add these two together and get 85. So the measurement of angle J plus 85 is equal to 180. And subtract 185 from both sides and find out that the measurement of angle J is equal to 95. So now I know that this is 95 degrees. And now I say, okay, these two angles are congruent. Which means if this is 95/56, 95/56, and then this is 29, by the triangle angle sum theorem, I could probably prove that that's also 29. And then I'd have all three angles congruent. That seems like a lot of information. Maybe the triangles are congruent. But angle, angle, angle does not prove triangles are congruent. We don't have any sides known to be congruent. So angle, angle, angle does not prove congruence. It only proves similarity. So this one has not enough information. All right, so we don't have to do a flowchart for that because there's not enough information to prove the two triangles are congruent. Okay, so now we get to this one. Before we get to this one, we have to add a reason that we're going to be using in our flowcharts, and the reason is called the reflexive property. All right, your reflexes are things that you kind of do automatically, right? So the reflexive property is for things that are automatic. The reflexive property says that anything is congruent to itself. What does that mean? It means that angle A is congruent to itself. Angle A is congruent to angle A. And that means that like side AB is congruent to itself. Side AB. And we use it in problems like this one up here. So in this one, I've got this angle and this angle here proven congruent. So I've got one angle and that's it. Now you might be looking at these and saying, hey, aren't these proven congruent? Well, not yet. We know that they're both 90. So I can prove they're both congruent because they're both 90 degrees. So these two angles are congruent. So now I've got one angle, one pair of angles proven congruent. I've got a second pair of angles proven congruent. But that's not enough. Angle, angle isn't enough. But if you notice that this side here, DB, it's part of the top triangle and it's part of the bottom triangle. So that is the same. So DB from the top is the same as DB from the bottom. That's the reflexive property. It's congruent to itself. So now we've got angle, side, angle on the top, and angle, side, angle on the bottom. So we have angle, side, angle congruence. So we can prove this. All right, so let's take out a piece of paper and do a flow chart for this one. All right, so part B's flow chart. So I'm going to start over here. I'm going to say that this angle, now I can't call it B because that would confuse you. You wouldn't know if I'm talking about the top angle or the bottom angle. So I'm going to call it angle ABD. So angle ABD is going to be congruent as this bottom angle down here. Again, I'm not going to call it B because you wouldn't know I'm talking about the bottom. So I'm going to call it CBD. Now nobody's confused. So CBD. So I know that those angles are congruent because they told me. They put the tick marks there. So that's given. All right, so I'm proving angle, side, angle congruent. So here's my angle. Let's do the side next. Now the side in between them is DB. DB on one triangle, and it's also DB on the second triangle. It's congruent to itself. And that's what I said right before we did this problem. This is the reflexive property. That DB from this triangle is the same as DB from this triangle because they're the same side. It's automatic. It's reflexive. So I've got an angle and a side now. And now I need these last two angles. Well, they didn't give me that they're congruent because I added that in orange right here. So what I'm going to say is what they did tell me is that these two angles are 90 degrees because they put this little box there. So I'm going to say that the measurement of angle, I can't just say D because there's a lot of angles there at D. So I'll say ADB. So the measurement of ADB is 90 degrees. Okay, they told me that. That's given. They also told me that this angle down here, I'll call it CDB. So they said the measurement of angle CDB is also 90 degrees. That was given. I had a room over there. All right, so since both of these have the same measurement, now we can say that angle ADB is congruent to angle CDB. Why are they congruent? Because they have the same measurement. That's the definition of congruence. All right, so these two lead to this conclusion. They have the same measurement, therefore they're congruent to each other. So I have an angle, a side, and an angle being proved congruent. So now that is enough information to say the two triangles are congruent. So I'm going to say that triangle ADB is congruent to triangle. Since I started with A, I have to start with C on the other one, and then DB. Okay, I've got an angle. I proved a side congruent, and I proved another angle congruent. So the reason for this is angle side angle congruence. There's my flow chart for B. All right, for C, we have this angle and this angle. So I got one pair of angles and nothing else. Now I do have reflexive again because this side is the same on the top triangle and it's the same on the bottom triangle. So that's a reflexive property. So I've got a pair of angles, a pair of sides, but I need three things to prove congruent. Now they did add on something here. They've got these parallel lines right there. Now this leads back all the way to Unit 1, and you guys I know have been skipping this stuff because you're like, I don't want to do it. But you've seen this before on your homework assignments. When you have two parallel lines, we have talked about this, two parallel lines and a transversal. This angle here and this angle here are what we call alternate interior angles. Alternate means they're on different sides of the transversal, and interior means they're inside the parallel lines. And all the way back at Unit 1, we found out that alternate interior angles, alternate interior, were congruent to each other. Okay, so that means that angle 1 is congruent to angle 2 because they're alternate interior angles. When you have parallel lines of the transversal, alternate interior angles are congruent. We have alternate interior angles in this picture up here. So even though it's not drawn to scale, meaning that these aren't drawn correctly, you can tell this is supposed to be parallel, but it doesn't look parallel. But we're just going to pretend it is because they tell us it's parallel. So here I've got my parallel lines right there. I would consider this one of the transversals. Okay, so parallel, parallel, transversal, and we do have alternate interior angles there. This one would be alternate interior angles with this one right here. Those are alternate interior angles. They're both inside the two parallel lines, and they're on different sides of this transversal right here. And alternate interior angles are congruent to each other. So what do we have? We've got angle, side, angle, angle, side, angle. So we're going to use angle, side, angle congruence again, which means we need to go back to the flow chart. All right, so back to the flow chart. Let's do a flow chart for C. So we're going to do C here. We're going to start with the part they gave us. So let's start with this angle here. Now we can't call it angle F because there's multiple angles at F. So I'm going to call that angle GFH. And it's going to be congruent to this one down here. I can't call it H because I got multiple angles at H. So I'll call it EHF. All right, they started with that information. So we knew that right off the bat because they told us. So that's given. So there's an angle so far. Now, we said this side, it wasn't given because we put the tick mark there, but we said the reason was the reflexive property. So we can say that FH from one of the triangles is congruent to FH from the other triangle. And it's this new reason right here, the reflexive property. Okay, so I've got an angle, I've got a side, and now I need more angles. So we marked these two. So let's say this angle we would call HFE. So we're going to say that angle HFE is congruent to angle, so I did this one, and now I'm going to use this one, FHG. And the reason is because alternate interior angles are congruent. We said these were alternate interior angles, and alternate interior angles are congruent. So I've got an angle, a side, and an angle. Therefore, I can prove the two triangles are congruent. So I can say triangle, let's start with FGH. So FGH is congruent to triangle, let's go, okay, start with F, so I have to start with H. So I'll do HEF. And the reason for that is angle side angle congruence again. There we go. All right, let's move on to the next page. I can find my next page. There it is. All right, on the next page. All right, so on D, well, they've marked these angles right there. That was nice of them. We can put a tick mark here and a tick mark there because of the definition of congruence. But I've got 4 here, but I don't have 4 there. That's it. I've got one side and one angle. That's not enough information. You have to have 3 things in order to prove they're congruent. So not enough info. All they needed to tell me was that this one was 4, and then we would have had something. We haven't covered side angle side yet, but we'll get to that next time. Anyways, next one. This one we're looking at, there's 5 triangles here. This triangle, this one, and then this triangle here. I'm going to do it in pink. So there's a triangle right there. That's the fourth triangle. And then this one in blue is going to be our fifth triangle. All right, so we're going to be looking at that blue and the pink triangle. So far what I see is that on the pink triangle, I've got an angle mark here, and on this blue triangle, I've got an angle mark. So I got one angle there. On the blue triangle here, I've got 2 tick marks, and on the pink triangle, I've got 2 tick marks. There's 2 angles. All right, remember we need 3 things, and I've got 2 of them so far. I've got 2 angles. Now the other thing is that reflexive property again. This side down here is from the blue triangle, and it's from the pink triangle. They share that side. So I do have 2 things. Now, is this angle side angle? Some of you would say, yes, it's angle side angle. Look, angle side angle. Those are angles from 2 different triangles. We have to look at the same triangle. So on the blue triangle, I've got angle, angle, side. This is from the pink triangle. I can't use that one. On the pink triangle, I've got angle, angle, side, and I can't use that because it's from the blue triangle. So I have angle, angle, side here, not angle, side, angle. So I'm going to do my last flowchart. There we go. All right, last flowchart for today. Let's move this up so you can see our triangle there. All right, we're on part E. Okay, so let's start with what they gave me. I'm going to start over here, angle D. I can say that angle D is congruent to angle C from the other triangle. So D's from the blue triangle, C's from the pink triangle. They're congruent because they gave us those tick marks. That's given. Next thing, from the blue triangle, I've got this angle B down here, but I can't call it B because there's multiple angles there. So let's call it angle DBA. So angle DBA is congruent. Now on the pink triangle, the 1 tick mark is this one. Again, I can't name it just A because there's multiple angles there at A. So let's call it CAB. So angle CAB. All right, so I got DBA from the blue one and CAB from the pink one. And they gave that information to me that was given. So I've got 1 angle, 2 pairs of angles, and now we're going to use this reflexive side. We can say that AB is congruent to AB. So AB from the blue triangle and AB from the pink triangle are the same thing. So automatically they have to be congruent to each other. That's the reflexive property. Okay, so I've got an angle proven congruent, an angle proven congruent, and a side proven congruent. I have angle, angle, side congruence. So now I can say the 2 triangles are congruent. I can say triangle, let's do DBA, that's the blue one. DBA is congruent to, so I started with D, I have to go over here to C, and we'll do CAB. That was really bad. There we go. That's beautiful. All right, so triangle CAB. And my reason is because I had angle, angle, side. So since we have angle, angle, side congruence, we are done. All right, now we just have 7-44. If the triangles were proven congruent in parts A through E, write a rigid transformation that would map one of the triangles to the other one. So when we have a rigid motion, remember it preserves the shape. So that's one way to prove the 2 triangles are congruent. So on part B, we knew that the triangles were congruent to each other. So we want to do some kind of rigid motion to prove that it is. So here's B. So if I want to match up everything, all I would have to do is reflect over this line right here. I would just pull this one, flip it. I'd take this one and flip it, and then this one would be on top of that one. So a reflection over DB would map this triangle on top of that one. Or I could take the top one and reflect it down over DB, and they'd be on top of each other. So I'm going to say that in order to get B on top of the other one, that I would reflect over BD. And that would put one of them on top of the other one. Part C. Okay, a reflection doesn't work on this one, and here's why. If I take this bottom triangle and flip it, the 2 tick mark angle would move up and be on top of the wrong angle. It'd be on top of the 1 tick mark angle. And this 1 tick mark angle would be on top of this 2 tick mark angle. So a reflection's not going to work. What we need to do is we need to spin this thing. So if I took this bottom one and spun it around the middle of this line, if I spun it, let's see, 180 degrees, this one would spin until it's right there. This bottom one would spin until it's on top of this one, and then E would be up where G is. So if we rotate 180 degrees centered at the midpoint of this side here, FH, that would translate one onto, or transform one so that it's mapped on top of the other one. So we're going to rotate 180 degrees, centered at the midpoint of FH. All right, last one is for E. So this one, we need this one over to here, and then we need this angle over top on this one, and then A needs to be moved over there. So it looks like a reflection of some sort, and here's where we would reflect. We would reflect kind of right through the middle of this one, so kind of where it's perpendicular, and then we could reflect it and they'd be right on top of each other. They'd be matching up then. So if we reflect, and it'd have to be over a line that's not there right now, so I'd just say like a line that's perpendicular to AB through the midpoint. So we're going to reflect over the line that is perpendicular to AB at the midpoint. And then one would be on top of the other. All right, that's all I got for you. Math hard. I'll see you later. Bye-bye.